Hello students, welcome to the discussion of sample paper of CBSE 2018. In our last discussion, we discussed section A and section B of the sample paper. In today's class, we are going to discuss section C of the sample paper. Let me tell you, section C will be having 12 questions and each question will be of 3 marks each. The maximum question will be numerical based, but a few can be theoretical based. So let's start with the discussion. As I told you, we'll be having 12 questions and each questions would be of 3 marks each. So you would be having an opportunity to collect 36 marks in this section. The questions will be typically in easy type and you need not to worry. The examiner may seek several conceptual understanding from you all. Now let's go with the first question of the day. We have all resistance in the diagram below are in ohms. Find the effective resistance between the points A and B in ohm. Now see, you can see the figure. We have to find the effective resistance between A and B. Now several resistors are connected as shown. Now what you have to do, you have to show several diagrams eliminating resistance as you move ahead. Now you see here, if you see this resistance 3 and 3, we can think of they are connected in series. So let's make a equivalent resistance so that 3 plus 3 will give you 6. So if I draw a diagram representing the first diagram, that will be somewhat like this. 3 and 3 I'll be having 6. So we will be having A and B, we are having 3 ohm. This 3 and 3 will give you 6. So let us mark this as 6 ohm. For clarity reasons, let me write it very clearly. So draw a stepwise diagram in this way so that the examiner finds it easy in correcting. This is 6 ohm and rest of the diagram you can draw as it is given. This is 3 ohm and so on. Again we have 6 ohm here as shown. So go on stepwise drawing the diagram. We'll be having the connections as shown and we had one 6 ohm more. So let me draw one 6 ohm more. Now you can see we have eliminated this 3 and 3 and we draw an equivalent resistance of 6 ohm. Now this 6 and 6 will be connected in parallel. As you can see that the potential difference across this 6 and this 6 is same. So this 6 and this 6 is connected in parallel. So 6 and 6, two equivalent resistance connected in parallel. That means their equivalent will be just 6 by 2, that is equal to 3. So if I eliminate this, I'll be having 3 ohm. So from here we will be obtaining a diagram. 3 ohm you take from here. So now we need to draw a diagram in this way. Rest of the diagram will be as it is. This is 3 ohm and then we have 3 ohm again and then we have 3 ohm again. Seems quite lengthier, but need not to worry because it's quite easy. Again this 6 ohm and again we have one more 6 ohm connected here. So this is how you have to show the connections. Now again we have reached here, 3 and 3 will be in series. This 3 and 3 will be in series. So 3 and 3 will equal up to 6. 6 and 6 in parallel. That means you'll be getting 6 and 6 again 3 ohm. Then again 3 ohm will be in series. So 3 ohm will be again, their equivalent will come out to be. I'm using this space. You can see here. Now I'm drawing the next diagram. From here this 3 and 3 will give you 6. So let me show you that this is 6 ohm. Next we have this 3 and 3. So let's complete the figure. We have this 3 and rest 3. Now this A and B we had already 3 ohm here. So next all resistance are given in ohm. So I am not marking the units since all resistance are given in ohm. Now again you see this 6 and 6 will be connected in parallel. This 6 and 6 will be connected in parallel. So take it their equivalent, that will be 6 by 2, that is 3 ohm. So 3 ohm again will be in series. So now if you go on drawing this diagram, you will be having 3 and 3 in series. So 6 and 6 in parallel, again 3 and 3 again in series. So you'll be having 6 ohm and 3 ohm will be in parallel. So finally you will be having 6 ohm and 3 ohm. You would be having this. If you go ahead eliminating resistance in this way, so finally 6 ohm and 3 ohm in parallel, you can easily find out their equivalent values. What I'm going to do, I'm going to rub this diagram. Hope you have taken down the equivalent resistance will come out to be, we know two resistors connected in parallel, it's simply their resultant is R1 R2 upon R1 plus R2. So do this, apply this formula. R1 is 6, R2 is 3. So 6 into 3 divided by 6 plus 3, that is, this will come out to be 6 into 3, 18. 18 divided by 9, that is 2 ohm. 6 into 3, 18 divided by 9, that comes out to be 2 ohm. So equivalent resistance of this diagram, of this connection, comes out to be 2 ohm. So you should have a knowledge of how to eliminate resistance just by seeing the circuit. If you see the circuit, it seems to be complicated, but it's not a complicated question. It's a very easy question. If you show all these steps, you're going to get full 3 marks for this question. Let's proceed with the next one. You see here, the EMF of a cell is 6 volt. When 2 ampere current is drawn from it, then potential difference across its terminal remains 3 volt. What is the value of its internal resistance? Now see here, this question is quite easy, let me tell you. But examiner may check your conceptual understanding. If you know it, you can simply solve this. This will be the diagram. This is the cell diagram. Let's say this is a terminal A, this is terminal B. It's given that EMF of cell is 6 volt. So we have its EMF as 6 volt, that is given. Internal resistance we want to evaluate. When 2 ampere current is drawn from it, then potential difference across its terminal remains 3 volt. We know that if current is I through the circuit, we know potential difference existing across the terminals is given as V equals to E minus IR. Substitute all the values, you can evaluate the value of R. V is given as 3, E is given as 6 minus I into R. Now I is given as here 2 ampere, which we will be substituting. Finally go ahead, you will be having I into R is equal to 3. Therefore R comes out to be 3 by I, that is 3 by 2 ohms, that is 1.5 ohms. So we got this. This is our value of the internal resistance of this cell. So easy question if you have the conceptual understanding. Sometimes luckily you may get an easy question of 3 marks and you can easily solve it, you will get the complete marks. So after this, let's go ahead with the next question. Here you see here, a galvanometer having 30 divisions had current sensitivity of 20 microampere per division. It has a resistance of 25 ohm. So the given here, first of all, let me write the basic things. It's given here current sensitivity of 30 division, current sensitivity of 20 microampere per division. Now see, each division can measure up till 20 microampere. So 30 division can measure up till, so galvanometer can measure up till where? Think of, it is 20 microampere for one division. So this will give you 20 into 30, that is 600, 2 into 3, 600 microampere. This will be the limit of galvanometer, that is this maximum current can flow through the galvanometer. This is what we can get from it. Now its resistance is given as 25 ohm. So what I am writing, resistance of galvanometer Rg is equal to 25 ohm. This is the value of resistance of galvanometer that's given. First part of the question, how will you convert it into an ammeter measuring up to 1 ampere? The maximum current that can flow, that is 600 microampere. Now how to convert this into an ammeter to measure up till 1 ampere? So first of all, let's solve the first part of the question. So first part, if you want to convert it into an ammeter, we know that to convert galvanometer into an ammeter, we actually connect a resistance, that is a shunt, in parallel with the galvanometer. So we have to make a connection somewhat like this. Is the galvanometer, and here we are connecting the shunt. Now you have to measure 1 ampere, that is current can flow, that is 1 ampere. So current should break from here, this point. The maximum current, let I am marking this as Ig, and that is actually equal to 600 microampere. Rest of the current will flow through this shunt, and this shunt resistor I am marking as Rs. Now you see here in the question part, it has been asked, how will you convert it into an ammeter measuring up to 1 ampere? That is, we want to evaluate the value of this shunt. So easy, not too difficult. Now one thing, we know the value of resistance of the galvanometer and we know current through galvanometer. Now if both are connected in parallel, that means the potential difference across each of the resistance of galvanometer and this shunt resistance should be same. So potential difference is same, so therefore potential across shunt should be equal to potential across galvanometer. Now what I'm going to do, potential across shunt will be how much? I minus Ig multiply it with shunt resistance Rs is equal to Vg. Now across this Ig into galvanometer resistance, this I am writing as Rg. Now you have all the values, you know Ig, you know I, you know Rs, you want to calculate Rs, you want to know, you know Rg. Let's substitute all the values. Will be having shunt resistance is equal to Ig into Rg divided by I minus Ig into, that's it, we are done. We are done. Substitute all the values. You know Ig value is given as 600 microampere. So can we write this as 600 into 10 to power minus 6, that's not a problem, into resistance of this galvanometer, that is 25 ohms, divided by I minus Ig, that is 1 minus 600 into 10 to power minus 6, or you can directly write 6 into 10 to minus 4. With all this calculation, you can find out the resistance of this shunt. I want you all to note down till here. I will start from here. Okay, now see here, hope you have taken down here. You have to simply evaluate it. You have to simply calculate the value. What you can, after calculation, find that the value will come out to be 0.015 ohm. So this is the value of shunt resistance required to be connected to the galvanometer in parallel, so that you can convert this galvanometer into an ammeter, which can measure up till 1 ampere. Now let's go with the second part of the question. How will you convert? Let me rub this so that you can see it clearly. How will you convert this ammeter into a voltmeter up to 1 volt? Now we know that to convert galvanometer into a voltmeter, we have to connect a resistance in series. So if I make a diagram, the diagram will be somewhat like this: shunt and galvanometer. We want to measure up till, you see here, we want to convert it into voltmeter up to 1 volt. So we want to measure up till 1 volt. So potential difference to be measured, that is 1 volt. Shunt resistance we want to evaluate, galvanometer resistance is given as Rg, that we know already, that's 25 ohm. Now you see here, let's say current Ig only can flow through this resistance. Now potential difference existing across these two ends should be equal to potential difference across this, potential difference across this. That is, I am writing V, that is existing across this ends A and B, should be equal to Ig into Rs. Why I am writing Ig? Because Ig is the maximum current that can flow through the galvanometer resistance. So we cannot increase current further more than this. So I am taking the maximum value plus Ig into Rg. We know its value is 1 and we want the value of Rs. So Rs will come out to be V upon Ig minus, and if you take this, this will come out to be Rg, because Ig into Rg, take here, divide by Ig, you will get this. Now substitute the values, you will get V as 1, Ig, that is 6 into 10 to power minus 4, I am writing directly, minus the value of galvanometer resistance, that is 25 ohm. If you evaluate this, you will get this as 1641.67 ohm, somewhat like this. You will be obtaining the answer. So finally the result is this, that this much is the value of shunt resistance to be connected in series with the galvanometer to convert it into a voltmeter, so that which can measure up till 1 volt. You should remember the basics, that to convert a galvanometer into an ammeter, connect the resistance, shunt resistance in parallel, and if you want to convert a galvanometer into a voltmeter, connect the shunt resistance in series. Let's go with the next question. 14th question. Find the equivalent capacitance of the infinite ladder shown in figure between the points A and B. A and B, 1 microfarad, 2 microfarad, again 1, 2, 1, 2, it's continuing. it's continuing. Now see, this is a case of infinite resistance. So if you remember the method how to do this, you can easily solve this. Now see here, you can see here after 1 and 2, same pattern is continuing. So you'll be writing, let equivalent capacitance of this combination is X or C, whatever you want to make it, you can write it, let it is X. Now if infinite resistance has an equivalent of X microfarad, so what we can do, just using the first part of the circuit, we can eliminate the entire part with this value X. So what I'm going to write, I'm going to draw the diagram. We can draw the same diagram in this way, 1, 2, and since here we have, oh, it's a case of capacitance, so let's use here capacitance. Now you see here, can we eliminate this entire circuit with this diagram? 1. Now see, all values are given in microfarad, so I'm not especially mentioning microfarad, but you can do it in your examination. That would be good, so that the examiner may not get confused that why you have used 1 and 2 only. So use it with proper units. You see here 2 and X are connected in series. So the value of 2 and X, now see equivalent capacitance of 2 and X. Equivalent capacitance of 2 and X which are connected in series of 2 microfarad and X microfarad and X connected in series. We know the value of capacitance which are connected in series, that is just C1 into C2 divided by C1 plus C2. Let's do that. We know that C equivalent for connection in series, it's C1 and C2 upon C1 plus C2. So you'll be having 2 into X upon 2 plus X. 2X upon 2 plus X will be having this. Now this entire combination 2 and X is connected in 1 microfarad in parallel. So the net equivalent capacitance will become, we know directly you can add, so net equivalent capacitance comes out to be, net equivalent capacitance, this is nothing, you have to simply add this with 1 microfarad. So C net will be 1 plus 2X upon 2 plus X. Simply evaluate its value now, and you will obtain the resultant. Now see, if you go ahead, let's C net is how much? C net is already, we know that that's equal to X. So that will be X is equal to 2 plus X, take its LCM. Here you will be obtaining 2 plus X plus 2X. See here, X plus 2X, 3X, 3X plus 2. You take this 2 plus X here, you will be having 2X plus X square is equal to 2 plus 3X. Not a problem, it's quite easy because we had 2 plus X plus 2X. X square, 2X minus 3X will give you minus X, minus 2 is equal to 0. We are getting a quadratic equation. You can solve this quadratic equation very simply. You can factorize it, you will be getting X minus 2, X plus 1. That is, just you simply factorize it, you will get this value. Now from here, the value of X will come out to be either 2 or X is equal to minus 1. We know that X equal to minus 1 is not a feasible answer, that is invalid answer. So X equal to 2 is a feasible answer. So the equivalent capacitance or net capacitance will be actually 2 microfarad. That is the resultant of this infinite circuit that has been shown here, and hope you would have noted down here. That's okay. And I believe that you would have drawn this diagram whenever you find an infinite circuit, whether in the case of resistance or in the case of capacitance. See, what you do, you have to eliminate from here and you take the equivalent as X, then connect the X here and find the resultant. This is how you are going to do. Then we have question number 15. This is a very good question, and sometimes you may get a tough question in 3 marks, so you have to do it wisely, because you also get an easy question in 3 marks, so you have to do it so that on time that will be balanced on time scale. You see here a long straight solid conductor of radius 5 centimeter. Now see, we have here solid cylindrical kind of conductor whose radius is 5 centimeter, carries a current of 3 ampere, which is uniformly distributed over its circular cross section. Now see, this current is present all along this area. This current will be flowing through this area as I am drawing the diagram. Okay, so you should have the idea it's not only moving through the central axis of this conductor. Find the magnetic field induction at a distance of 4 cm from the axis of the conductor. We want to find here the magnetic field induction. Relative permeability of the conductor is equal to 1000. That is also given. That is, we are provided with relative permeability mu r is equal to 1000. Current 3 ampere is uniformly distributed. Now, what we are going to do, since current is uniformly distributed, we want to find out magnetic field induction at this distance of 4 cm from the central axis. First, what you do, draw a circular cross section of radius 4 cm. So, if I draw it, I will be having somewhat like this, a circle somewhat like this. Okay, now you should be having the idea I have drawn a circle. Now, current is uniformly distributed along this entire cross section. So, how much current would be flowing through this part of the circle that I have drawn? This will be how much? This will be nothing but I equals to total current divided by the total cross section. That will be pi capital R square, if this is capital R, multiplied by the area of this circular cross section, that is pi into small r square. So, what are we going to obtain? We are going to obtain I into small r square upon capital R square. We have this. Now, current you know, small r you know, capital R you know, so you will be having the value of current flowing through this cross section. Now, you see here, find the magnetic field induction at a distance of 4 cm. Recall the Amperes Circuit Law, that is what you have to use. So, what I am going to do, now the picture part is over, I am going to use the Amperes Circuit Law. So, using Amperes Circuit Law, and if you remember, this law says that integral B dot dl is equal to mu I. Now, here I am using mu, that is finally I am not using mu naught, because this is actually we have taken in a space of this conductor. So, I am using mu. So, this mu will be nothing but actually in this case it will be mu naught into mu r into I and integral B dot dl. Now, again you see the diagram, integral B dot dl. Let us see the magnetic field that is present tangentially at each part of this periphery of this circular cross section, the magnetic field that will be present tangentially. Now, because the conductor is moving along this line, so you have to, the magnetic field will be just, it would be directed along this direction. Try to understand. You have to imagine it, magnetic field will be moving into this circular cross section. So, we know that integral B dot dl is equal to mu naught I, mu into I. Now, substitute all the values, integral B dot dl, this will give you B into 2 pi r, this is equal to mu naught into mu r. Now, the value of current, that is actually in this case it is a small I, this is what we have written. So, small I is how much? I into small r square upon capital R square. We have this. Can we substitute the value or not? See, the requirement is magnetic field induction we have to evaluate. See this, magnetic field induction, this is what is required. So, magnetic field induction, that will come out to be, you see 1 r and 1 r will be cancelled out. So, B will come out to be mu naught is nothing but 4 pi into 10 to the power minus 7 mu r, that is given as 1000, multiplied with current I, that is how much? You may just refer to this diagram, it is given as in this way as 3 ampere. You see in the question 3 ampere. So, we have this as 3 ampere multiplied by this small r, that is 4 centimeter. Okay. Since we are doing in proper SI units, so what we are going to do, I am going to write centimeter in meters, 4 into 10 to the power minus 2 divided by 2 pi, and now we have r square, that is actually nothing but 5 into 5 into 10 to the power minus 4. Can we solve this easily? That is not a big thing. Now, if you solve this, you will see that this pi and pi cancels out, this 2 will get 2 times here, and rest of the things can be easily evaluated, and you can find out the numerical value, that will be 9.6 into 10 to power minus 3 Tesla. You can check the numerical value after calculation. You will get this much as the answer for this question. Now what we have done, you should remember the Amperes Circuit Law. Here you have to draw cross-sectional area of radius 4 centimeter. I am just eliminating this part so that you must be having a clear idea how we have taken the approach. Just draw a circular cross section at the radius 4 centimeter, and then you have to use Amperes Circuit Law wisely, that is integral B dot dl is equal to mu naught into I. Next we have, when 10 volt DC is applied across a coil, current through it is 2.5 ampere. We are having coil, so coil will be somewhat like this. Volt DC is applied 10 volt DC. Current through it is 2.5 ampere. If 10 volt 50 hertz AC is applied, current is 2 ampere. Calculate reactance of the coil. Now think wisely. This is a coil. If DC source is applied and current is measured, that is 2.5 ampere. That means it has some resistance. First of all, with the given first data, 10 volt DC and 2.5 ampere, can we calculate the value of resistance of this coil? Resistance of coil will be nothing, just simply what you do, we know it's V by I. When 10, you have to also mention when this is for 10 volt DC connection. So I am writing 10 volt DC connection. Mention it separately in your examination paper. I have not mentioned it here, okay, to save time. You have to mention when 10 volt DC is connected, the resistance of the coil will come out to be V by I, that is actually 10 divided by 2.5, that is equal to 4 ohms. We got it. Now when AC is connected, so what is happening? In the case of AC connection, the coil will behave somewhat like this. This is coil and this will be its resistance. And here we have the AC source. AC source and its 10 volt, that is the RMS voltage given, and we want to, let us say, chi L is the reactance of this coil and resistance is given as 4 ohm. Now we know that the total circuit resistance will come out to be for 10 volt AC connection, for 10 volt AC connection, see here what we will be having, the impedance of the circuit Z is nothing but V by I. You have to mention impedance of the circuit. Impedance Z will come out to be, I am using this part of the board, impedance Z is nothing but V by I, that is equal to 10 volt AC and I is 2, that is actually 5 ohm. Now we know that when resistance and this coil are connected in series, this Z will be nothing but under root of R square plus chi L whole square. Now we want to find out the value of chi L, that is what is required. So what I am going to do, I am going to rub this part and we know Z comes out to be 5, square both the sides will be having 5 whole square is equal to R whole square plus chi L whole square. So chi L whole square comes out to be 5 square minus R square, that is nothing but 25 minus 16 because R is 4. So chi L will come out to be 3 ohm, that is reactance of the coil comes out to be 3 ohm in this question. The smart part of the question is this, you will be thinking that coil is applied, your mind, your senses may not go towards the fact that you have to find out the resistance of the coil, because the coil is also having resistance and inbuilt resistance. That is what you can evaluate with the first part of the question. In the next part, you have to make the connection showing that this resistance and the coil are connected in series as I showed you in the diagram, and further you have to find out the impedance of the circuit with the second data given, and thereby you will be reaching on to the result. Next question 17. A coil, a capacitor and AC source of RMS voltage 24 volt are connected in series. So we are having a coil and a capacitor are connected in series by varying the frequency of the source, and maximum RMS current of 6 ampere is observed. Now see, it's given the condition is that you vary the frequency, so you are going to get the maximum RMS current. If you remember, in the case of inductor, capacitor and a resistor connected in series, whenever you are going to vary the frequency, a case of resonance will occur when the maximum current is going to flow. So at maximum current, resonance is said to be happening. So for maximum current, resonance should take place. Now when resonance should take place, that means coil and capacitor of no use in the circuit, the only usage will be of the resistance. Now here again, think like in the previous question, the coil is having some resistance, there we are going to derive the resistance, and resistance will come out to be voltage of 24 volt, current of 6 ampere. So resistance will come out to be V by I, that is 24 V by I, that is equal to 24 by 6 ampere. So this is nothing but 4 ohm. So we got the resistance of the coil, that is given as 4 ohm. If this coil is connected to a battery of EMF 12 volt and internal resistance 4 ohm, then calculate the current through the coil. Now we are going to connect the coil, this coil with a battery of EMF 12 volt and some internal resistance. You may see here is connected to a battery of EMF 12 volt and internal resistance 4 ohm, then calculate the current through the coil. This is 4 ohm. Now this resistance is given as, although it is coil, it is going to have some resistance. Now I am drawing an equivalent diagram to show you that it has got some resistance, and this resistance we have evaluated as 4 ohm. Clear? Now it has been asked what is the current through the circuit, calculate the current through the coil. Now current through the circuit is very easy. We have a simple circuit. The current will come out to be EMF of the cell upon net resistance, this R plus this small r, that is 12 divided by 4 plus 4, that is equal to 12 by 8, that comes out to be 3 by 2 or 1.5 ampere. So simple it is to calculate. Now what is required in the question, most students get confused here. Maximum current, coil, capacitor, how to think of? You have to think that is a case of resonance. So you should know that when resonance occur. And when resonance is occurring in a circuit which is having inductor, capacitor and resistance, so inductor and capacitor will actually cancel out net effect and only resistance will be in operation. If you can make the phasor diagram, you will get that idea. So when resistance is connected, calculate the value of that resistance, that is due to the coil. Now when coil is connected in series, that means its resistance is taking the active part in the connection. So you can calculate the current using this circuit. And hope you are learning step by step that what deep conceptual understanding of each chapter is required, so that you can easily solve all the questions in a board examination. This one is an optics question. A small candle 2.5 centimeter in size is placed 27 centimeter in front of a concave mirror of radius of curvature 36 centimeter. At what distance from the mirror should a screen be placed in order to receive a sharp image? Describe the nature and size of the image. If the candle is moved close to the mirror, how the screen have to be moved? Now let us write down the various data that has been provided in the question. Small candle 2.5 centimeter in size. First of all, size of the candle we know 2.5 centimeter is placed 27 centimeter in front of a concave mirror. So the distance, the object distance, that is u. So mention here object distance. Object distance u is given as 27 centimeter. So this is minus 27, that is required. Radius of curvature 36 centimeter. So radius of curvature, I am writing this as 36 centimeter. At what distance from the mirror should a screen be placed in order to receive a sharp image? Now see here, first of all we know focal length is nothing but r by 2, that is 36 by 2, that is will be 18 centimeter. And since it is a concave mirror, so this focal length should be minus for concave mirror. You have to write each step by step clearly depicting each step. Okay. Now we have to find out the value of image distance. So using mirror formula, mention some statements every time, whatever statements you are going to use. So 1 by v plus 1 by u equals to 1 by f. Use it. You will get the required answer. 1 by v will be how much? It will be nothing but 1 by f minus 1 by u. Substitute the values. 1 by f, that is 1 upon minus 18, minus 1 upon u, u is actually minus 27. So what are you going to get? 18 and 27, take the LCM as 54, or you can simplify this. You will be obtaining first 1 upon 27 minus 1 upon 18. So take LCM as 54, 27 into 2, so 2 and 18 into 3 minus 3, you will be having minus 1 by 54. That means the image distance will come out to be 54 centimeter. So I am rubbing this part and we have obtained v is equal to minus 54 centimeter. That is, the screen should be placed at a distance of 54 centimeter from the mirror. So screen should be placed at a distance of 54 centimeter from mirror to obtain the sharp image. That is quite obvious, to obtain the image. So how would the screen look like? How would the image look like? This is a concave mirror. Now see here, its focal length is given here, its focus will be here, that will be, this focal length is actually 18 centimeter. The object is kept here. If I draw the ray diagram, first ray should pass here, second ray you can take through pole and let it pass with the same angle. So we are having this. This is the final image. Now see the next part of the question. We have got screen should be placed at a distance of 54 centimeter. Describe the nature and size of the image. Nature, whether it's real or virtual. Yes, it's a real image because rays are actually meeting. It's a real image. So I'm marking here. It's a case of real image. And its size, we are required. What is its size? Now magnification produced. Magnification is nothing but m is equal to minus v by u. We all know this. Now m is equal to minus v by u. That means m is equal to minus value of v is minus 54, value of u is minus 27, comes out to be minus 2. Now size of image will be equal to minus 2 into size of object. So height of image, you have to write completely, size of image is equal to minus 2 into size of object. Write it completely so that examiner is clear of everything, and he has got no scope to cancel your marks, to deduct your marks. So you have to write this size of image minus 2 into size of object. Size of object is given as 2.5 centimeter. So let me use this part. So size of image, I am writing hi, that is minus 2 into 2.5 centimeter, this comes out to be minus 5 centimeter. Minus 5, minus sign is denoting that it is inverted, and 5 centimeter, it is twice the twice the object size. Size of the image we got here. If the candle is moved close to the mirror, how would the screen have to be moved? Now see here, if the candle is moved close to the mirror, this image will move further apart, further distant away from the mirror. This image will move distance away from the mirror. So if you move it towards the focal length, towards the focus of the mirror, the image will go on further away from the mirror. So in second part, in the last part, you have to write, if you are going to move the candle towards the mirror, the screen has to be shifted away from the mirror. Okay. So three parts we had. We have to evaluate where the image is formed. Second, nature and size, and third, how the screen should be shifted. For each part, you will be getting 1 mark. So this way, you have to calculate each part of the question. 19th question. A ray of light passes through an equilateral prism. Equilateral prism, that means each angle will be 60 degree. That angle of incidence is equal to angle of emergence, and the latter is equal to 3/4 of the angle of prism. So we are having E is equal to 3/4. I am writing E, that means angle of emergence, is 3/4 of angle of prism, that is 3/4 of A, that is equal to 3/4 of 60 degree, that is actually equal to 45 degree. If you evaluate, we will get this as 45 degree. Calculate the angle of deviation. Refractive index of prism is 1.5. Now angle of deviation, we all know that del is equal to I plus E minus A. Now here it's given that angle of incidence is equal to angle of emergence. So simply you can write I plus E, that is E plus E minus A, 2E minus A. So 2E minus A, that is 2 into 45 minus 60. If you evaluate, you will get this as 30 degree. Easy question, but if you know the idea that the angle of deviation is calculated by sum of angle of incidence and sum of angle of emergence, and you deduct the angle of prism, you will get the value of angle of deviation. Quite easy question. Next, now we have Young's double-slit experiment. That now we have come to the wave optics. In Young's double-slit experiment, the fringes are formed at a distance of 1 meter from double slit of separation 0.12 mm. So we are given distance of screen from the slits, those are given as 1 meter. So capital D is 1 meter and small d is given as 0.12 mm. The distance of third dark band from the center of the screen. Now see here, how is the Young's double-slit experiment? This is somewhat like this. This is the screen, and these are the rays which are actually going and interfering, and finally the fringes are obtained here. This is slit S1, this is slit S2, this is the screen where they are interfering, and this is the central maxima point. Central maximum, central maxima. We want to find out this distance. First of all, we are required to find out the third dark band distance. We know for dark fringes, that is for destructive interference, the distance is given as 2n minus 1 lambda d by d. We can easily evaluate, substitute the values. Instead of n, you put here 3, and rest of the values are given to you. N is 3, so 3 into 6, 6 minus 1, lambda d by 2d, use here 2 also, that is also required. 5, the value of lambda is given here as 6000, lambda is equal to 6000 Angstrom, so use here 6000 into 10 to power minus 10 into capital D, that is 1, divide by 2 into small d, that is 0.12 mm, you will get this. Now you can easily evaluate this, and you can get the value of the distance of third dark band from the central maxima, I want you all to note down till here and start from here. Okay, now you would have easily calculate this value, and that will come out to be 1.25 centimeter, which I am writing here. That easily comes out to be, this y value will come out to be 1.25 centimeter. This can easily evaluate. Now the second part of the question reads as, let me rub this part, it's not required. Second part, the distance of third bright band from the center of the screen given lambda is equal to 6000 angstrom. Third bright band, the only thing we have to change the formula that we are going to use. So y will become n lambda d by d. This will come out to be n value keep at 3, lambda 6000, 10 to power minus 10, and capital D that is given as 1 upon small d. You can see here small d that's given as 0.2 mm. So let me write this as 0.12 into 10 to power minus 3. So you will get the required answer. You will get the required answer, and that will come out to be in meters. As you convert into centimeter, that will be 1.5 centimeter. This will be the 1.5 centimeter. This will be the answer for third bright band, the distance of third bright band from the central maxima. We get all the answers. Also, two parts of question, but directly formula based. If you know the formula, you can directly put up the values. You will get 1.5 and 1.5 marks for each of the parts. So in total, you will be securing 3 marks. Next question, that is 21. Light of wavelength 6328 angstrom is incident normally on a slit of width 0.2 mm. So we are given here slit width as 0.2 mm. Calculate the angular width of central maximum on a screen placed at a distance of 9 meter. Capital D is given as 9 meter. Now, how to find out the angular width? Now, what is angular width? Let me tell you. For any angular, suppose this is the screen, I will draw a complete diagram here. 0.2 and 9 are the values. Suppose we have the arrangement in this way. This is the screen, and let's say you want to find the angular width. Let's say this is the how the central maxima is located, let's say. So this angle will be the angular width of the central maxima. Now we know that this is actually how much. This will be the fringe width, which we know that this is actually fringe width. Fringe width is given as lambda d by d. So we know this value. Now the angle will be nothing but theta is equal to this distance, that is fringe width, divided by this radius, that is capital D. So W by D will be the angular width. This will come out to be lambda by small d. Put up the values, you are going to get the value of the angular width. If you substitute the values as given as lambda is 6328 angstrom, divided by small d, that is given as 0.2 mm. So 0.2 into 10 to power minus 3. So can we simply evaluate it? We will get the value in radians. So this will come out to be, if you evaluate it, you will get this as 0.2. Here we can do it 2 into 10 to power minus 4. So we will be having as 3, 1 and 6, 4 into 10 to the power minus 6 radians. This will be the value of angular width of the central maxima, that is 3164 into 10 to the power minus 6 radian, or you can write this as 3.16 into 10 to the power minus 3 radians. Remember, if you do calculation in this way, you are going to get the angle in terms of radians. So this was all about this diagram. Just see, this is the angular width. How are you going to calculate? Just take the fringe width, then divide the fringe width by this distance, that is given as d. If you divide it, you will get lambda by small d, and you can easily calculate the fringe width with this formula. Now let's go ahead with the next question. We are having a light of wavelength 1240 angstrom incident on a metal having threshold frequency 4.8 into 10 to the power 14 Hertz. Threshold frequency means this is the minimum frequency of the light required so that the photoelectrons can be ejected. What is the maximum kinetic energy of photoelectron? Now see, kinetic energy maximum, if you remember, this will be given as energy of incident light minus work function, that is given by chi here. Now hc by lambda, you substitute the values, you will get the result required answer. hc will be 6.626 into 10 to power minus 34 with proper units into 3 into 10 to power 8 divided by lambda, that is given as 1240 angstrom. Then here threshold frequency. So can we write the same formula as hc by lambda minus h mu naught, where mu naught is the threshold frequency. So minus, again I am writing 6.626 into 10 to power minus 34 with the value of mu naught, that is 4.8 into 10 to power 14 with proper units. If you do it, you will get the required answer, that will come out to be nearly 12.5 into 10 to power minus 19 joules. This will be the required answer. This will be 12.8. If you calculate, you will get 12.8 into 10 to power minus 19 joules. So this is the maximum kinetic energy of the photoelectrons which will be ejected. Now if light has intensity 100 watt per square centimeter, then calculate number of incident photons per square meter per second. Now it's given, we are given with the intensity. Intensity is what? It is simply power per unit area, that is power of the light that is incident on a particular area. So power per unit area will give you the intensity. That is actually energy incident per unit area per unit time, that is actually intensity. Now it has been asked here, calculate number of incident photons per square meter per second. Intensity is 100 watt per square centimeter. Number of incident photons will be simply intensity. It will be simply intensity upon energy of one electron, that is, it is energy of one photon, energy of one photon. If you do it here, you will get the number of photons emitted per unit area per unit time. Substitute the values here. You have this value as 100 watt per square centimeter. So let me write here 100 watt per square centimeter. You have to do it in proper SI units, hc by lambda. So what I am going to do, hc by lambda, I am going to write here 6.626 into 10 to the minus 34. And here we have the value of lambda as 1240 into 10 to the power minus 10. So that will come in the numerator. You can easily solve this and you will get the required answer. Now see one more thing. Here we are given in centimeter square. So first of all, we have to convert it into meter square. So we will be having the required answer as, converted into meter square, you will be having the resultant as 100. Now see, per square centimeter. So convert into meter square, you will be having 10 to power minus 4 here, and then only you will be having a meter square, because centimeter square will be in the denominator. Convert into meter square, you will be having this multiplied by 1240 into 10 to power minus 10. Then write all the required things. Easily you can calculate the number of photons emitted per unit area per unit time. Then you will get the required result. I want you all to note down this required result, that is 62.43 into 10 to power 22 photons per unit area per unit time, meters per unit meter square. And then let me write it separately. Let me write this way, number of photons per unit area per unit time. This will be the given answer of the number of photons emitted per unit time. You can even write 6.2 into 10 to power 23. Number of photons per unit area in meter square per unit time in second. So this was all about the discussion of section C of the sample paper. Now it is a comparatively numerical based part that we have solved here. in exam you may be having 1 or 2 theoretical based questions. Now in the overall paper there is no choice given, but in between questions you may have a choice, like say question number 11 has only one question, question number 12 has only one question, question number 13 may be having 2 questions. So you will be having a choice to choose one among them to answer, but you cannot choose. Suppose 12 questions are given, choose any 10. You are not given, overall choice is not given, but in a particular question you may be having attempt only one among those 2 questions. So this was all about the discussion of section C. I'll meet you in the next lecture class, that would be discussion of section D and section E. Till the time, do practice well, and I wish you all the very best for your board examination. This is me, Abhinav, saying thank you to you all.